Oh wait. You're in his class now. I said hi to you. No, I didn't interpret. I'm sorry for the delay. I record every class. I'm using a different program because it's a Zoom program, but it's like a Zoom recording. It's running my computer too hot. So, hey everybody. Happy Monday. So last time I saw you, I think you were taking a happy Mondays. First time I see you this week. Last time I saw you, you were taking a test or just took a test. Please remember, honor code, and I mentioned this as you were leaving, don't talk about this within earshot of other people. And then another teacher told me that he heard people talk about the test in the hallway. So if you're going to talk about a test after test, make sure it's quiet with directly to someone else. And when I say quiet, I mean like be thoughtful about it, not just hopeful that no one's around you. Right? Just like, hey, let's talk about the test and go over to a corner somewhere to talk about it, but not in a big group right outside the classroom. Fair enough? Please keep that in mind. Just as part of the honor code, talking about the test really is not a violation of the honor code, but telling people, other people, what, or giving any sort of indication what's on the test is an honor code, including like how you felt about the test, if it was easy, if it was hard. These are violations of honor code. What's not a violation of honor code is, okay, it was on the appropriate material, it was on what we expected, something like that. Anything more than that, though, is too much information. So please be mindful of that in the future. Definitely, I don't want any teachers coming to talk to me to tell me that my students were in the hallway all together discussing a test. It's just not appropriate. Even though I understand you had just gotten out of the test and like, I need to talk about it, is probably what you may have felt like. Also, I understand that there is, I'm sorry for people that haven't taken it, but there were varying levels of satisfaction in how you performed. So just so you know, we account for improvement. So if you feel like you did poorly on this one, don't sweat it. It's not the end of the world. You should not be thinking about dropping the class because of one test. But remember that you are accountable for everything we do in class. When I give you hints, tips, and tricks, I recommend you take them to heart. If you go back and do everything the way you've been doing since Algebra 1, often it works, but often it's not very effective. So please keep that in mind as we're going through the course. I think I'm going to be passing back the tests next time. I haven't gotten through them yet. I haven't finished grading them at all. And some are great, some are not great. So it'll all work out in the end. If you are concerned about your personal test, come and talk to me after I give the tests back. That makes the most sense. So we have a new unit coming up. Unit 2. Dun, dun, dun. Rational functions. So you can see on mine, there's something that's not on yours. Day 5, we are going to have a quiz. Now, when I talk about day 5 of the unit, this is different from days of the cycle, which I know is confusing. So when I say day 5, that just doesn't mean day 5 of the cycle. Like this is day 1, happens to be day 1 of this cycle, but our day 2 will actually be day 3 of the cycle, but the second day of the unit. So on the 5th day, we'll be having a quiz on days 1 through 4, and then we'll have an exam on day 9. I'm not sure about what date that is, but I'll get back to you about that. I'll make sure to put both of those on your hub calendars. Okay, let's get to it. Today is review of previous knowledge. And if you don't have this knowledge, then this is new knowledge. And let's make it happen. I feel the need to get this timer out of here. Maybe put it up here. That's better. Maybe up on the left. Yes. What just happened? Can I not maximize this? Boy. There we go, that one. Okay. This unit will be analyzing and understanding rational function. When you see the word rational in a math class, what's it referring to? What word? A ratio, otherwise represented as a fraction. Like rational number is a number that can be represented as a ratio, or a ratio of integers specifically. So rational functions means we're going to have a fraction with some sort of functions, with x being in the denominator. Working with rational expressions, equations, and functions depend heavily on your previous work with two big concepts: fractions and factoring. In general, a rational expression is a function in the form, excuse me, I can't say that expression is a function. An expression f of x over g of x. And f of x could be a constant. Both are polynomials. So examples: x squared plus 3x plus 7 over x cubed minus 4x plus 2, right? That's a rational expression. Or 1 over x minus 3, rational expression. X over 1, not a rational expression. At the bottom must be a function of x. Top could be a constant, but bottom not. Okay, I'll give you a minute to do these. These very difficult starting problems. Do a brief check with your neighbor, make sure they're getting the same thing you are. And in each box, if you could talk about what property you use, like why can you do what you did? Maybe don't write it down, but talk about it. Why can you do what you did? At least think about it. Okay, I know number one is pretty difficult. You just subtract 11 from the top and bottom. Is that how it works? Subtract 11 from top and bottom. Yeah. 1 over 9 or something like that. Yeah, of course, yeah. No, you obviously canceled the 2's. Is that what you did? The 3's? The 6 is the greatest common factor, so you got 2/3. Why can we do that? Other than that's what you've always done. Why is that okay? What's that? What? Okay, they're factors, so why could you cancel factors? Race, you have an idea? They're in the same ratio? Okay. What does that have to do with the idea? So in the same ratio. So you mean 2 is to 3 as 12 is 18? Okay. Okay, nice. Did you have an idea? Okay. Property lets us cancel. And so what is that related to? I think and no one's been wrong here so far. Seems to me that's the identity property of multiplication. The inverse of that. Do you know what the identity property of multiplication is? Yeah. This is like if you start with this, you can multiply by 6 over 6. Can't you? You can multiply by anything, any value of 1, or any expression of 1. So it's just the opposite of that. Instead of multiplying by 1, we're actually dividing by that 1. Bring it to simplest terms, 2/3. 1/3 plus 5 halves. We need, of course, a common denominator. You need that anytime you are adding or subtracting. Do you need it for multiplication too? It works for multiplication, but it's much too much work. You don't need it for multiplication, so please don't use it for that. Of course, we're going to multiply top and bottom of the first one by 5, the top and bottom of the second one by 3. Would it make sense to put everything over 15 immediately? Just say 5 plus 6. Is this kind of something like what you did to get that 11/15? Why do we need common denominators? Josh, you have an idea? Yeah. Why do we need common denominator? Why can't we just say 1/3 plus 2/5 is 3/8? Oh. I like that, adding units. And maybe you made pizza graphs when you first started doing these. Do you remember that? When you started first representing fractions of pizzas or slices of pizza or something? Okay, so they need to be equal slices ultimately. So common denominators, I like that. Thank you. 6/7 minus 9, 7/8. What's the answer for that? Negative 15. Negative 15 over 72. Well, maybe 72 is not the least common denominator, is it? It is, yeah. Oh, I'll do this the long way. Okay, times 9 times 9. So you have that 72, and then the top is 40 minus 63. So negative 15. So allegedly this could be simplified. When should you simplify things? Oh, if you can, right? If you could get to a whole number or something. Factor out the 3, we'll cancel the 3's. So 5 over 24. Negative 5/24. I will deduct a point if you don't simplify a fraction in an answer. I don't care if in your work you can simplify something, but if your answer isn't fully simplified, you can count on the deduction. Should I do 3 times 25 for this next one? You can, or while the numbers are small, cancel, right? 3 goes into 21 7 times, 5 goes into 25 5 times, so we got 5 7s. The expression cross-canceling is something I will never use, and I expect you to never use it. Why? Why don't I like the expression cross-canceling? Nor most math teachers. What's wrong with cross-canceling? Josh, 300. If you want to cross-multiplying. Canceling is just canceling. Numerators and denominators cancel if they have common factors. So just cancel them out. Okay, we know for this one, you just 7/8 times 4/3. Should I multiply 7 times 4? No, before we do that, let's cancel. 4 goes in h 2 times 7/6. Done. Yeah, I think we just got to do order of operations. The grouping comes first, and then I think you have something like 30 as a denominator, and 36 plus 25. What does that equal? 61? You got them all? Okay, then you have all the tools you need for this section. That's great. Yay! Let's see how it goes. Oh, let me... Okay, so we get complicated and abstract. We're moving on from numbers into letters and variables. On the same thing. Okay, so multiplication, all we have to do is cancel any common factors. When you see the x squared minus 4, difference of squares. You think of that when you see it? Expression like that. So go ahead and finish this one. I'll give you some time to do the whole top row. Just the top row for now. In fact, with the labels, we are done I think there's a typo in this last one. I'm pretty sure. Oh, no, there's no typo. Never mind. Did you get them all? X squared minus 4. X minus 2 times x plus 2. Anything cancel? Yeah, x plus 2 cancels. Anything else? One of the y's cancels. Does it make sense if I cancel like this? Just kind of cross out the 2. Now, you're responsible for your notes taking. If you want to put a 1 there, you can. When I cancel out the x's, it's tough to cancel out an x, isn't it? I have 2 slashes, so maybe something like this, and then cancel that. So where you're left with, you never have to multiply it out. That's not more simple. You may, but you're doing more work if you multiply it out when the answer is already right. So my recommendation is leave it factored, please. Is that what you already have? Maybe one step further. I trust that it is. The second one, 2 times x plus 4. Hopefully you factored out that 2x squared. Did you flip it? Do you know you don't actually have to? You can. I hope that makes sense. It's 2 times x before divided by x before is less 2. X squared by x is just x to 2 over x. Should be what you're left with, isn't it? This doesn't always work out that cleanly, so it's a good idea to multiply by the reciprocal. That x cancels with one of those. This cancels, leaving 2 over x. X squared minus 2x minus 15. Two numbers are multiplied to be negative 15 and adds me negative 2. Do they exist? Yeah, what are they? Thank you. It's that one. Why do we have to factor this? So that we can cancel x squared plus 5x. Factor out the x. X plus 5. X cubed plus 27. Is that anything we can work with? Sum of cubes. In order to factor a sum of cubes, you have to just know how to do it. Have you already discussed this with your neighbor? How to factor a sum of cubes? I'll give you a minute to check in with the people around you. Not just how do you factor this?
Like the base of that. I can exactly. Yeah.
Okay. Do you remember?
No.
Who'd like to share with us? Who remembers? Eva, 300. Okay. Does this look right? Nice. Yeah. Perfect. Yes. There is something a squared minus 2ab plus b squared. But what is this? What is that? Does that look familiar at all? Yeah, that's what a minus b quantity squared is equal to. Right, which is confusing that they look so similar. So it's up to you to remember what. This can never be factored. This kind of can never be factored. Unless it comes from maybe some of sixths, then maybe it could be something. If it comes from a sum, you get a cube, then you cannot factor it. While we're at it, go ahead and, with your neighbor, see if you could generate the difference of cubes. Okay.
Yeah.
Short minus times long. What is it? If you want to finish it off. Thank you. Nice. The teacher from last year would be very proud right now. And soap, does soap make sense when we're talking about these? As an acronym? Yeah. Same opposite, always positive or always plus. When we factor the sum, we start with the sum. Then the opposite, always plus. B squared. Minus an opposite, always plus b squared. But x cubed plus 27, we know that 27 is just 3 cubed, so we just kind of fill in what's A and what's B. So this is going to be x plus 3 times x squared minus 3x plus 9. Now that it's all factored, we can start canceling. If you do something like this, if you do this, you're in for a world of hurt for that problem. Be careful. You cannot like factor out an exponent, so don't even try. You have to use one of the forms of sum or differences of cubes. So the x plus 3's, they both cancel, and that's it. Oh, one of the x's cancels. Seems like they could have done a better job setting this up for fun. Do you know what x minus 5 times x plus 5 is? X squared minus 25. Although there's no need to multiply that out, you can leave it in factor form. It's just fun to multiply it. What's the relationship between these two factors? X minus 5. They're called, starts with a C, they're called conjugates. It's fun to multiply conjugates. That's always a difference of squares. So you can leave it factored or not. But yeah, we're looking for this. Any questions? Okay. Moving on. Okay, we're adding and subtracting here. The denominators are almost the same. How do I get these to be the same? Do you want to discuss what are you going to do to make these the same?
Yeah.
You're keeping the first one, right?
Yeah.
Okay, suggestion. Who'd like to tell us a suggestion? Yes, Maya? On top and bottom, you mean? Okay. Are we good with that? Did anyone else think that? Multiply by -1 top and bottom? Perfect. I love it. X squared plus 5 over x minus 4. Now when I multiply this 2x minus 6 times -1, does it make sense that that's just going to be equal to 6 minus 2x? But the difference just flips, and the same thing happens on the bottom. 4 minus x becomes x minus 4. And now we can combine these. So we have x squared minus 2x plus 11 over x minus 4. I'll give you a chance to do the fifth problem in this set. I can finish the whole thing. Oh, is he asking for the name? Oh my goodness. Thank you. Let's do that. Let's do that after we do this. Okay, in the first one, 16, we factored out the x, so we have x minus 2. In the second one, you make that a -1 on top, and then x minus 2, is that what we did? Are we good up to there? Let's simplify that a little bit, shall we? Instead of subtracting that negative, let's make this an addition problem. Nice and cool. Second one, of course, we still have to multiply by x over x. That would have been nice and efficient, yes. So this leaves us with 16 plus x. Why not? You can only cancel. You can only cancel factors. It did. And what's the negative one? And then I think good question. Yeah, before I move on to the next one, let's talk about the domain. State the domain restrictions, i.e. the restrictions that must be placed on variables so that expression is defined. Remember, you can never divide by zeros, so just make zeros are never in any sort of denominator. So for this first one, we see that x cannot equal 0 or -2. Also, y cannot be equal to 0. And do you see why x can't be equal to -2? And no denominators could ever be equal to 0 at any time in the problem. So you don't just look at the very end. Look at the start and the end of the game. Yeah. Mostly the first one is what you're looking for. For the second one, x cannot be equal to 0. Anything else? Why not -4? What's that? Yeah. You can't have that 0 right there. Even from the start, this can't be -4 here because starting with the value of this entire second fraction, 0. You can't divide by 0. You can look at it from the start. It's not as obvious, but eventually that can flip over here. You see the 0 in the denominator. Anything else from that second one? No. Oh, looks like I need some more room for this next one because I know that x can't be equal to 0. X can't be equal to -3. Could it be equal to negative? Oh yeah, there it can't. Good. Or -3. Anything else that it can't be equal to? Why not +3? Well, let's go to y's. Y can't be equal to 0. Could x be equal to 5? Yeah, numerator is okay to have a 0. So is there any other value that needs to be excluded? Yes, Josh? Why 3?
Because we have the last equation, x squared minus 3x minus 9.
-9?
Oh, is that not what it is?
It's always plus.
Oh,
Plus 9. But I think even if it's -9, I think that would work. But thank you, we have to figure out when this expression, this triangle, is equal to 0 and then exclude those values. So I'm going to do this down at the bottom of the page. X squared minus 3x plus 9. I'll set that equal to 0 and then discount all of those. How shall I solve this problem? Quadratic formula? You don't want to use completed square? You may, but completed square is only linear coefficient is even. So we'll do this on x equals to 3 squared. Did I do it right? Just for a little bit of algebraic fun. If I can't grab that 9, -3 inside. I'll do it the slow way. 27, 32. So 3 halves, plus or minus 3 over 3 over 2. I. Is that comfortable? So I'm going to put that on my list of excluded values. It also can't be equal to, just in case you want to, for some reason, plug in a 3 halves plus or minus 3 root 3 2 halves I. You can't. I mean, I can do it, okay. Any questions? Yes. Good question. For complex numbers, I do expect it to be in complex number form A plus BI. If you didn't separate it, I probably would take off points in the beginning, but I say separate it, and then ultimately, I do want it in that form. So you've listened to me for a long time. I'm going to give you until 12:27 to zone out. If you want to stretch, you may. Oh, yeah.
How am I supposed to submit a homework?
I put up a link on the hub where you scan it up there. Now, you don't have to do every page. You can do first and last of each chapter if you want.
Oh, yeah, I didn't do that.
Okay.
I want to get like points out of it. Wait up. I was confused. I was going to give you a paper.
That makes sense. I appreciate that.
Can we use the factoring for, or I guess we can. I was going to ask one second, do the report should do that. Maybe let's go back to it. Right?
Depends on the profession. And what people
Two left, that's the
yeah, that's 3 cubes. Okay.
one.
Okay. Oh, this is cube, I think. Yeah, this is already factored. Okay, family. 2 plus 3 plus 2 plus 3 plus 2 plus 3.
So we that's
Yeah. Yeah. It'll be on the hub. Thank you, particularly to Josh for being the only one back on time. Okay, so maybe my I haven't been clear in my expectations of you. The break is not like in between class type of break. Break is a break in listening to me speak. So it's a time for you to, if you want to put your head down, if you want to stand up and stretch, if you really need to go to the bathroom or grab some water, then yes. That's the time to do it if you can wait. But for the entire class to leave, is not something I want to see every day. Sorry, please stay in the room unless there's something you really need outside. And remember, on time, if I say we're starting at 12:27, that means when this clicks to me 27, that's when we begin. Because I'm not beginning until at least most of you are here. At least in the beginning. I don't want to leave you out. I also don't want to have to wait for you to come back. So in the future, just make sure that, go out, come back in plenty of time if you need to go out. Or just stay in the classroom and zone out. But really, it's not a time to roam. Make sense? Hey, look at this. Rational functions. We're adding 3 fractions. We're going to need a common denominator. We didn't need it for any of the other ones. It was all multiplication. But now we are adding and subtracting. But we have 3 different things. What should we do? Now that third one, we of course are going to factor it. So x squared minus 5x minus 6 becomes, what is it, negative 6 and plus 1, which is pretty nice because they share our factors with the other fractions. So for this first one, 1 over x plus 1, oh yeah, my laptop's already acting weird. And multiply top and bottom by x minus 6. Does this look familiar to you? That x over x minus 6, I'm going to multiply that by x plus 1 over x plus 1. And that last one, and leave it as it is. Can I make one big fraction? The denominator of which is... Yeah, I should have left this factored actually. X minus 6 and x plus 1. X minus 6, x plus 1, the top. I'll give you a chance to finish the top. Embedded in here is checking to see if we're going to fall for a common error. We'll call out what that error is to see if your neighbor fell for it. Oops. X minus 6 plus x squared plus x. Did you get that? Minus 5x plus 2. Did you get the plus? And that's the one. And that's going to be tested multiple times, so I suggest you keep it in mind. That's subtraction sign. Just make sure everything after it's being subtracted. So this should be through. From here, I think it's going to be fine. We'll keep this in standard form, so we have x squared minus 3x, thank you, plus minus 4, minus 3x. X minus 6 times x plus 1. We're not necessarily done until we check to see if we cancel anything. So the top, we factor, does anything cancel? X plus 1 does cancel out, leaving us with x minus 4 over x minus 6. What should I do with those x's? Leave them. What should I do with the 4 and the 6? With that 2 and 3? I asked that question, and some people are thinking, don't be ridiculous. And I hope that's what you're thinking. But I can't tell you how often I see people cancel the 2 and the x's. So keep in mind, the only time you can cancel is if they are factors. You can only cancel factors. So if you haven't factored something, don't cancel it. Promise? Please? Good question. For instance, like if I were to multiply this out, and thank you for asking. If I were to multiply out this step right here, don't put this in your notes, by the way. X squared minus 3x minus 4 over, I think this was x squared minus 5x minus 6. For someone who's not canceling, like not respecting the rule of cancel factors, they might say, oh, there's x squared and x squared. Cancel that. Or there's a 4 and a 6, so I cancel the 2 and the 6 right here. Even though 2 is not a factor of the top. You can only cancel factors. So if you want to cancel this, you must factor it first. And if they're common factors, then you say bye-bye. So remember, you can only cancel factors. And I guarantee some of you are not going to go by that. Even though you promised, you cancel crazy stuff. Like plus ones. Oh, did they say something about domains? No. Let's do domain. X can't be equal to 6 or negative 1. Okay, here's a little bit of a trick problem, I believe. Find x plus y quantity squared. Okay. I'll give you minutes to think about this and to do what you can. Spill the beans. Discuss with your neighbor. Maybe they have an idea of what to do. If they don't, there are plenty of other people around you. Oh. They getting anything? Okay, so I don't want to spend too long on this because we do have other stuff to do. It's kind of a trick problem. I'm going to separate this into things that we have and things that we want. We want x plus y squared, which we know is the same thing as x squared plus 2xy plus y squared. Is that something you should know? Yeah. Here we have that this is true. Equals 2 and xy equals 3. So I already see, and don't you already see that we have this xy here? So that I'm just going to replace that with 3, so that middle term is 6. I just have to figure out what x squared plus y squared is. Is it 1? Let's see if we can take the reciprocal. I know that 1/2 plus 1/2 is equal to 1. Can I just take the reciprocal of these and say that 2 plus 2 is equal to 1?
No. She was saying how like for the 1 over x squared plus 1 over y squared, instead of the x squared plus y squared equals 1/2.
Oh, so flipping everything.
Yeah.
So okay, so if you could do that, then you should be able to do this. Flip this, and flip this, and then flip that last one. I know the first one's true. I think the second one is not true. So be careful about just using properties. If it were multiplication, I think it would have worked. But addition, subtraction, that messes things up. Josh, you have an idea?
If we make a common denominator with the first equation data,
So multiply top and bottom.
2 equals y squared plus x squared over x squared times y squared. That equals, another way of saying that second one is y squared plus x squared over xy. Each xy is 3 times 3. So it's 9 is the denominator, and then x squared plus y squared is the numerator, and still equal to 2. And if you multiply 9 by the both sides, it's x squared plus y squared for the numerator. And there as 8.
Is his logic sound? Nicely done. Wow. X squared plus y squared is 18, so I have 18 plus 6. 24. Whew. I have to go on if you want to hang out a bit after. It's kind of a trick problem. Okay, so you can talk about it. Thank you. Okay, when solving rational equations, okay, we have to be aware of restrictions. So here, this is a little bit different. I prefer solving rational equations, but you have to be very careful that when you're solving rational expressions, you're doing it appropriately. Like, of course, at x squared minus 8x plus 12, we need to factor into x minus 6 and x plus 2, minus 2. I think that works, doesn't it? Now, you might be tempted to combine the two expressions on the left, and you may, but I'm going to do it differently by just canceling all of the denominators. Now, how am I going to do that? By multiplying, and let me rewrite this so that it's very clear what the denominators are. Multiplying both sides by whatever I need to multiply to cancel the denominator on both sides. So I'm going to multiply both sides, since this is an equation, by, well, if I want to cancel x minus 6, I have to multiply by x minus 6. If I want to cancel x minus 2, I have to multiply by x minus 2. I'm doing this on both sides. When I distribute, do you see what's left here in that first term? Do you see that it's just x minus 2? The x minus 6 is canceled. Bless you. And when you distribute here, x minus 2 is canceled, leaving us with, nice. I'm going to leave it separate for now, but yeah, go right to that. Equals 4. Now here I'm fine canceling, but I would never put a line through either one of these, because I have to use both of them lines. You see, if I try to cancel this right here, maybe I forget to distribute that to the other side. The canceling of the x minus 6 just happens in my head. And you can see that the equation that we have right now is actually kind of nice. X squared minus 6x plus x minus 5x minus 6 equals 0. Did I do that right? I skipped a little bit. X minus 6 times x plus 1 0. So x equals 6 or negative 1. Why not?
Yeah, 6 is an extraneous solution, but if you plug it in,
You never have a bond equal to 0. So on a test or quiz, I want to see that you arrive at that solution, then you exit out. You have to write the word extraneous solution.
If you left the denominator here, would it just cancel the x minus 6 is going to get factored?
when you said canceling it,
Yeah.
you already get
No, but like, wouldn't it just cancel the factor of x minus 6? Then you wouldn't have to think about the strings expression, which is pretty simple.
Well, I think we get this just on top of a fraction of this denominator. Oh, sorry, and then you say that would cancel.
No, it would cancel, so you don't like need to worry about like the extra solution.
Oh, that's true. Good point.
I'm gonna move on. Oh my goodness. I don't think we have time for anything else, do we? Is this class over 1? Or? It's over 1, isn't it? Okay, so we have 15 minutes. Okay, we have time. Let's see if we can do this one. The next page.
What is that minus 6 plus?
So, check with your neighbor at any point. Maybe just make sure that they're pursuing. Does it work out? Does it answer? Did you get something? So we're multiplying both sides by how many factors? 3 factors. X minus 3, x minus 7, and x minus 11. I'm using super shorthand notation. I'm not doing left and right. Like specifically here, though, I will distribute to everything. So this 3x minus 4 will be multiplied by x minus 11, and I will put parentheses around that. Are we comfortable with that? Minus x minus 8 times x minus 3. I hope that you're seeing where this is coming from. These three factors multiplied by this fraction, these three cancel, we just x minus 3 on top. Lastly, this equals x minus 5 times x minus 7. Let me make these so there. They look like a human wrote it almost. Okay. Now what? Distributes. Now it's just a mess of algebra we have to get through. 3x squared. I see a negative 4x minus 33, so negative 37x. Be careful here. I hope this works out. It does? Okay, good. So what is this? Negative 26x plus 20. Oh, look at that. Do they both work? Like there are only 3 excluded values. None of them, and it doesn't match any of those. Any questions? Okay. What does this function intersect the graph of this function? In order to find where two functions intersect, you set them equal to each other. So I'm not going to go over that one. I'll let you do that on your own. The inequalities. Before I talk about example 4, I'm going to do some notes on page 6. You know that if a times b is equal to 0, then a or b must equal 0, yes? This is called ZPP, zero product property. I hope we're comfortable with it. It's a beautiful concept, and it should be almost intuitive. If something times something equals 0, then one of them is equal to 0. Just be careful. If you have something like a times b is greater than 0, would you please discuss what comes from here? If a times b is greater than 0, what do you know about a and b? Okay. Who'd like to tell us? What do we know? Yes. A and b have to have the same sign. What do you think about that? Either both positive or both negative? You see how you have to think about it a little bit more than ZPP? I heard also neither one could be 0. Are we good with that? More than that, in fact, either both positive or both negative. How about if you have something like a over b is less than 0? Hey, Josh. Right. A and b have to have different signs. So we keep that in mind when you're doing inequalities. Don't treat it like ZPP. Don't say that a is greater than 0 and b is greater than 0. Although that's true, there's another case where a and b are both less than 0. So you have to analyze a little bit when you're dealing with inequalities. So maybe for your notes, if you want to put something down, analyze a and b greater than 0, or A and B both have to be less than 0. And it's depending on the case, so analyze it. So we have something like this. Solve the rational inequalities. X squared minus 1, what three words are running through your head? Difference of squares, yes. X plus 1, X minus 1, and on the bottom is, do you recognize what this is? X plus 4, quantity squared. So we know that there are three numbers that give us 0. Any other number will give us either a positive or negative number in the quantity. Does that make sense? If you plug in any of these two numbers, 1, negative 1, or negative 4, you will get a 0. We don't care about that. The question is, when is this fraction going to be greater than 0? If you plug in any one but those three numbers, we'll have positive and negative numbers. So, what kind of analysis do we do? Or what's the method you use for something like this? Remember? Josh, you remember what it's called?
I think you could do a number line, but I think you want to do arbitrary.
Oh, no, definitely number line. Definitely number line. This is called boundary algorithm. Does that sound familiar from maybe Mr. Biggie's class or something like that? Or someone at the middle school? Who knows? Still works. Keep your numbers in order. Goofballs. Keep them in order, but this won't work. I'm going to plug in any number but those. Should I put 0 on this number line? They go into 0 if that's one of the numbers that makes a 0. Right now we see how many different regions are there. There's 4 regions, so I'm just going to choose a number in each region, like less than negative 4. Any number less than negative 4? Negative 5. At 0 in any of the you're right, it's undefined. We're looking for the various numbers between positive and negative.
When it comes to y,
yeah. What makes this a 0? So those numbers will give us a non-positive or non-positive value. So I just want to find anything that makes it 0, so I'm putting not there. Any other number will either make a positive or negative number. And I plug it in. Like when I plug it in negative 5. I don't care if it's a 6, or I care about it, because this is positive. When I plug it in, I'm sorry, negative 5. It's going to be negative. This is negative. As negative times negative over, actually the positive, so it's going to be positive, isn't it? I don't actually have to plug it in like a square. But what I'm doing now is, in my head, I'm thinking negative times negative divided by a positive. That gives us positive numbers no matter what I plug in there. Does that make sense to fill out your pluses? You could do true. I put pluses in. Going between negative 4 and negative 1 is a number like negative 2. Negative 2, that gives us negative times negative over, which are positive. So negative times a negative over a positive, which gives us all positives there. In between negative 1 and 1, 0 gives us positive times negative over positive, which yields a negative number. Now I'll plug in a billion, or any number greater than 1. A billion, okay. Positive times positive. So that is called linear analysis or number line analysis. That's what I expect you to use. Let's also mark where this is equal to 0 and where it's undefined. We know that negative 4, that's not going to be anything. At negative 1, that is a solution, isn't it? Because it's asking equal to 0. And a positive 1, those are also equal to 0. So, yeah. So I did everything in between. Like I figured this one on 0, this one on 0, but I didn't figure out exactly past the values. The negative 4 I plug in, which is undefined. That's never going to become my solution set. Negative 1 when I plug in. That would equal to 0. That 1 is equal to 0. So I feel like those could be part of my solution set. And I could have done that first. Maybe that would have been wise. So my solution here, when this is greater than or equal to 0, well, we start at negative infinity. This should be done in interval notation. Goes up to negative 4. In parentheses, thank you. We'll do a union here if you like. And then from negative 4 to negative 1, brackets, and 1 with brackets to infinity. If you want to do that algebraically, you may. But interval notation is nice and clean. I was going to tell you about this next one. You might be tempted to cross multiply, but it looks like a proportion that only cross multiply if it's equal to. First step here would be to set it equal to 0. Combine the factors, or combine the fractions, and do the same process that we did.
We'll combine factors and multiply by x minus 4 this group. Because we don't know if they don't know if we have the inequality of
Yeah, don't cancel anything with this. What we can simply move that over, set it equal to 0, combine the fractions. Yeah, don't multiply. Have a great day, folks. That was a lot. Your homework will be on the hub on my math lab, so make sure to check that.
Thank you.
What's that? Do we finish them?